Hey everyone, imagine running those crazy, powerful AI models, the stuff behind those super smart chatbots, right on your laptop.
Yeah.
And not just running them, but running them fast.
Right.
Well, guess what? It's not just possible, it's happening.
Yeah, it's pretty amazing.
And you actually sent me some research on these things called hybrid CPUs and how they're totally changing the game for AI, especially for these things called LLMs, large language model.
Yeah, LLMs.
We're going to deep dive into all of that and how researchers are really squeezing every ounce of performance out of these chips.
Really fascinating stuff.
So when we talk about these hybrid CPUs, what we're really talking about are CPUs with different types of cores, right?
Yeah, exactly. Some are designed for just raw performance, like real powerhouses.
Yeah.
And then others are built for efficiency, so they can run for a long time without using a ton of energy.
Oh, so it's kind of like, I don't know, like a track team or something.
Exactly, like having sprinters and marathon runners all on the same team.
I like that.
They each excel at different things, and by combining their strengths, you can get some incredible results.
Makes sense. So we've got this specialized team of processors, each with their own kind of skill set. But how does this hybrid approach actually benefit AI processing?
That's where the real magic happens.
Yeah.
Think about training one of those large language models,
Okay.
something that can like understand and generate human-like text, right?
Yeah.
Those models are incredibly complex
They are.
and require a ton of processing power. So by strategically dividing up the workload between these specialized cores, you can get a huge performance boost.
So it's like having those sprinters handle those like short bursts of intense activity,
Right.
and then the marathon runners kind of take care of those long haul tasks.
Precisely. And the fascinating thing is this isn't just one company doing this. This is like Qualcomm, AMD, Intel.
Wow.
They're all embracing this hybrid architecture.
Okay, so we're talking about dividing and conquering, making sure each core is really working on what it does best. But, one thing that I found really interesting is that researchers have managed to run these powerful LLMs on just regular client CPUs.
Right.
I mean, making them incredibly fast. I read that they even exceeded human reading speed.
Yeah, that's right.
They're doing this using something called 4-bit quantization.
hmm
How does that even work?
Well, think about it this way. They've figured out how to compress the data that these LLMs need,
Okay.
shrinking it down to a much smaller size so the CPU can actually process that information much, much faster.
Okay, so it's kind of like packing a suitcase super efficiently.
Exactly.
You can fit way more in there without needing a bigger bag. But, why is this CPU speed so important when we have all these other powerful processors like GPUs and NPUs that are designed for AI?
It's a great question. You see, even though those GPUs and NPUs are super powerful, they still often rely on the CPU to actually feed them the data.
Oh,
So it's kind of like having a super fast race car that can only go as fast as the pit crew can refuel it, right?
yeah, yeah.
If the CPU is slow, it creates a bottleneck,
Right.
slowing down the whole system.
Okay, so even with that supercharged engine, you need a smooth supply chain
Exactly.
to keep things running. But, with this hybrid design, isn't there a risk that the faster cores are kind of held back by the slower ones?
You're absolutely right. The traditional way of handling this parallel processing, just dividing the tasks equally among all the cores,
Yeah.
it doesn't work as well with these hybrid CPUs.
Okay, so then what's the solution? How do we prevent those faster cores from just twiddling their thumbs?
That's where this research gets really interesting. They've come up with what they call a dynamic method
A dynamic method, okay.
of parallel processing that's way smarter.
Okay.
So instead of just like statically assigning tasks, it constantly monitors each core's performance and adjusts the workload on the fly.
So it's kind of like a relay race where the coach is constantly assessing each runner's speed and stamina and then dynamically changing the strategy to ensure the team achieves the fastest possible time.
Precisely. You got it.
I like that analogy. So it's like having a super smart coach who knows exactly how to get the best performance out of each team member.
Yeah.
But that sounds really complex.
It is. It is.
How do they actually figure out how fast each core is working in real time?
Well, they use something called performance ratios.
Performance ratios, okay.
Now imagine you have a sprinter who can run 100 meters in, let's say, 10 seconds.
Okay.
And then you have a marathon runner who can cover that same distance in, I don't know, 15 seconds.
Okay.
The sprinter would have a performance ratio of 1.5 compared to the marathon runner.
Okay.
So when you divide up a task, you would give the sprinter, 1.5 times more work to make sure they both finish at roughly the same time.
Makes sense. So they're really analyzing the strengths and weaknesses of each core
Yeah.
and then dividing up the work accordingly. But if these ratios are constantly changing, I mean, how does the system keep up?
Right.
It's got to be like trying to manage a team where everyone's speed is just fluctuating all the time.
You've hit the nail on the head. That's where the real innovation lies, and we'll delve into that, how that dynamic adjustment actually works, in the next part of our deep dive.
All right. Sounds good. So we've got this super smart system, right? It's constantly analyzing the performance of each core, and then it adjusts the workload to kind of maximize efficiency.
It's pretty amazing.
It's like, I don't know, a real-time strategy game going on inside the CPU.
It is.
Now, I'm curious, how does this dynamic adjustment work in practice?
So imagine you have this complex AI task, right?
Okay.
Something that needs both that raw processing power, but also energy efficiency.
Okay.
So the dynamic method comes in and figures out which parts of the task are best suited for each type of core. It's like a chef, deciding which ingredients go on the stovetop for a quick sear and which ones need to simmer slowly.
Gotcha. So it's not just about throwing all the processing power at the problem.
Right.
It's about being strategic and using the right tools for the job.
Exactly. And the coolest part is that it's constantly adapting, right?
Yeah.
So let's say the E-cores, those efficiency cores, are kind of getting bogged down with a particular part of the task.
Okay.
Maybe they're struggling to sift through a huge data set or something.
Okay.
The system recognizes this, right?
Okay.
And it's like, okay, let's shift some of that workload over to the P-cores, the powerhouses.
That's right.
Those guys can just crunch through that data.
Right.
It's all about maintaining that perfect balance, making sure everyone is contributing and nobody's just sitting there, idle.
It's like, I don't know, a perfectly choreographed dance or something.
It really is.
But doesn't all this monitoring and this constant task switching, I mean, doesn't that create a lot of overhead? Wouldn't that slow things down?
That's a great question. And yes, there is some overhead involved, but the researchers have been really, really clever in minimizing it. Remember those performance ratios we talked about?
Yeah.
They've actually built in this really smart filtering mechanism that makes sure that only significant changes actually trigger those adjustments.
Gotcha.
It's kind of like having a coach who only intervenes when absolutely necessary.
Right.
They don't want to create unnecessary disruptions to the team's flow.
Right. So they've struck this balance between responsiveness and efficiency.
Exactly.
So making sure that the system stays agile, but it doesn't get bogged down in micromanagement or anything.
Right.
That's really impressive. You mentioned earlier that this dynamic parallel method works across different types of CPUs.
Yeah.
Does that mean it's not limited to just Intel processors?
You got it. This isn't just about Intel's hybrid architecture. It's about a fundamental shift in how we think about parallel processing. The core concepts here, this dynamic task allocation, this performance monitoring, can be applied to any system that has these heterogeneous processing units.
So whether it's like AMD's Ryzen AI processors,
Exactly, yeah.
Qualcomm Snapdragon platforms,
Yep.
I mean, the underlying principles are still relevant.
Totally.
Okay, that's really exciting. It means this technology could potentially revolutionize AI processing, not just on specific hardware, but kind of across the board.
Across the board, yeah, that's right.
But I have to admit, all this talk about performance ratios and dynamic allocation, it's still a bit abstract for me.
Okay.
Can we walk through a concrete example of how this method actually handles a specific task?
Absolutely. Let's take, for example, matrix multiplication.
Okay.
This is a fundamental operation in a lot of AI.
Right.
Picture it as multiplying these massive grids of numbers.
Okay.
Something AI models do all the time. Now, imagine you're running this operation on a hybrid CPU, and let's say it has 4 P cores, 4 of those performance cores, and 8 E cores, the efficient ones.
All right, so I'm picturing a team of processors tackling this giant math problem.
Exactly, yeah. So the dynamic method comes in, and the first thing it does is it analyzes each core's performance capability.
Okay.
And let's say it finds that the P cores, those powerhouses, are twice as fast as the E cores for this particular task.
Gotcha. So the P cores are sprinters in this scenario.
Exactly.
Ready to crunch those numbers.
Ready to go.
So instead of naively dividing that matrix multiplication task into 12 equal chunks,
Right.
the system gets a little bit smarter,
Right.
much smarter. So then the thread scheduler, this is like the team captain, right?
Exactly.
Steps in and allocates the work proportionally.
Yeah.
It might give each P core 2 chunks of the matrix to work on,
Right.
while each E core gets just 1.
Exactly. And that way,
So the faster cores are given more work to do,
Ye-
ensuring that everyone kind of finishes at roughly the same time.
exactly. That's exactly right. This ensures that all the cores are working at their optimal pace,
Right.
maximizing the overall efficiency.
It's like a well-conducted orchestra where every instrument is playing its part in perfect harmony
Yes. Love it.
to create this beautiful symphony of, processing power.
Yes. Symphony of processing power. That's beautiful.
And this dynamic adjustment is happening constantly throughout this entire process.
That's right.
That's mind-blowing. How does all this impact the actual development of AI models?
Oh, that's a great question.
I mean, does it change the way researchers are approaching the design and training of these models?
It's a fantastic question, and it highlights this really fascinating interplay between the hardware and the software in AI.
Yeah.
Traditionally, model development and hardware optimization were often seen as like separate domains, right?
Right.
Researchers would focus on creating the most powerful AI models without necessarily thinking about the specific hardware they'd run on.
Right. It's like designing a race car without thinking about the track it's going to be racing on.
Exactly.
Yeah.
But with the emergence of all these specialized AI chips,
Right.
these hybrid CPUs, GPUs, NPUs,
Yeah.
there's this growing realization that we need to kind of co-design the hardware and the software
Correct.
to get that optimal performance.
So it's like a two-way street. The hardware influences how the AI models are designed, and the models are tailored to exploit the specific capabilities of the hardware.
Yeah.
It's like a symbiotic relationship.
Precisely. And this research we're talking about on these dynamic parallel methods is a perfect example of how hardware optimization can actually drive innovation in AI model development.
I see what you mean. So knowing you have this incredibly efficient and adaptive hardware platform
Right.
really opens up new possibilities for model design.
Exactly.
Researchers can push the boundaries of complexity, knowing that the hardware can actually keep up.
That's right.
Imagine AI models that can process information at speeds previously thought impossible,
Yeah.
or models that can run seamlessly on low-power devices
Right.
without sacrificing accuracy. I mean, this dynamic parallel approach is paving the way for a new era of AI,
Yeah, totally.
one where the hardware and the software work in perfect harmony to unlock the full potential of this technology.
It's an exciting time.
It's like we're witnessing this paradigm shift in AI, where the boundaries of what's possible are just constantly being redefined.
Right.
I'm so eager to see what groundbreaking applications emerge from this synergy between the hardware and the software.
Me too.
But, before we get too lost in the future, let's bring it back to the present for a second.
Okay.
What are some of the immediate practical applications of this dynamic parallel method?
Right.
Like, what can people expect to see in the near future?
One of the most exciting areas is personal AI assistance. Imagine interacting with a voice assistant on your phone, on your laptop, that responds in real time.
Oh, wow.
No lag or delay. You're just having this natural back and forth.
I can definitely relate to that.
Yeah.
It's so frustrating when you're trying to have a conversation with your voice assistant,
Right.
and it just takes forever for it to process your request.
Yeah,
I mean, this would be a game changer.
it totally would be. And it extends far beyond just voice assistance.
Okay.
Think about real-time language translation,
Wow.
where you can have these seamless conversations with people speaking different languages.
Oh, wow.
Or imagine lightning-fast image recognition, where your phone can just instantly identify objects and then give you relevant information.
Yeah, that's cool.
All of these applications rely on these complex AI models
Right.
that could benefit tremendously from this kind of performance boost.
So we're talking about a future where AI is just seamlessly integrated into our daily lives,
Yeah,
providing us with this intelligent assistance.
right.
Personalized experiences,
Right.
all powered by these incredibly efficient hybrid CPUs.
Exactly. And it's not just consumer applications.
Okay.
Think about industries like healthcare, finance, manufacturing.
Okay, give me some examples. How could this dynamic parallel method be used in those sectors?
Well, in healthcare, you could have AI-powered diagnostic tools
Yeah.
that analyze medical images in real time,
Okay.
assisting doctors in making quicker and more accurate diagnoses.
I mean, that could be life-saving. What about finance?
Oh, in finance, imagine sophisticated fraud detection systems
Well,
that can just analyze vast amounts of financial data in the blink of an eye.
Yeah.
right? Identifying suspicious transactions before they cause any damage.
Wow. And what about manufacturing?
In manufacturing, picture AI-powered robots
Okay.
that can adapt to changing production lines, optimize their movements for maximum efficiency.
So that could lead to increased productivity, reduced costs.
Right.
I mean, this is incredible. It sounds like this technology has the potential to transform virtually every industry imaginable.
It really does. And it's all thanks to all this incredible work being done to unlock the full potential of the hardware.
Yeah.
It's amazing to think that all these innovations are happening right now, behind the scenes, driven by this desire to make AI more accessible,
Right.
more efficient,
Yeah.
more integrated into our lives.
It's like this chain reaction of progress, where each breakthrough is building on the last one, leading to even greater innovation.
Exactly.
I'm so excited to see where this journey takes us next.
Yeah.
But before we dive into the future, let's take a moment to reflect on the key takeaways from our deep dive.
Okay.
We've covered a lot of ground today, from the intricacies of hybrid CPUs to the transformative potential of this dynamic parallel processing
Right.
and the vast possibilities of AI across these diverse industries.
It's been quite a journey, hasn't it?
It has. We've gone from dissecting the inner workings of these amazing processors to exploring how they're revolutionizing AI
Right.
and its real-world applications.
That's right.
It's been an incredible ride. I feel like I've gained a whole new appreciation for how AI is evolving and the driving forces behind it.
I'm so glad to hear that. And remember, we're just scratching the surface here.
Right.
The field of AI is constantly pushing the boundaries of what's possible.
Yeah.
And the innovations that we've discussed today are paving the way for an even more extraordinary future.
I can't wait to see what breakthroughs lie ahead. But before we wrap up this episode, I want to leave our listeners with one final thought. We've talked about all these amazing things these hybrid CPUs can do for AI,
Yeah.
but technology always comes with trade-offs, right?
Yeah.
I mean, what are some of the challenges that researchers are still working on as they're developing this technology?
One of the biggest ones is just fine-tuning that dynamic workload allocation,
Okay.
making sure the faster cores aren't waiting on the slower ones and vice versa.
Yeah.
It's a delicate balancing act.
Right.
You know, it's like a chef constantly adjusting the heat under each pot to
Yeah.
make sure all the dishes finish cooking at the same time.
So it's not as simple as just dividing up the work and letting the cores run wild.
Right.
There's a real art to optimizing this whole process.
There is. There is.
So what are they doing to kind of tackle that challenge?
Well, they're developing all sorts of sophisticated algorithms
Okay.
to analyze the specific characteristics of each task
Yeah.
and then dynamically adjust the workload distribution in real time.
Wow.
They're also looking at ways to predict future workload demands to make the system even more proactive.
So it's like having a chess grandmaster inside the CPU,
Yeah.
thinking several moves ahead
Right.
just to make sure everything runs smoothly.
That's a great way to put it.
And it's not just about optimizing for speed either, right?
Yeah.
I mean, you mentioned those E-cores are designed to be energy efficient. Yeah.
So are researchers looking at how to maximize their contribution to kind of reduce the overall energy footprint of these AI systems? Absolutely. That's a huge focus,
Okay.
because even with all this talk about performance,
Yeah.
we can't forget about the environmental impact.
Right.
It's all about finding that sweet spot
Yeah.
between speed, efficiency, and sustainability.
And I imagine another challenge has got to be just the sheer complexity of these AI models themselves.
Oh, absolutely.
I mean, as these models become more and more sophisticated,
Yeah,
they need even more processing power, more memory.
right.
I mean, this pushes the limits of current hardware
It does.
and demands constant innovation in chip design and architecture, right?
It's a constant race.
Yeah.
The AI models are getting more complex
Yeah.
and the hardware's trying to keep up.
It's like we're witnessing this technological revolution unfold in real time.
We really are.
It's incredible to think how far we've come,
Yeah,
and even more exciting to imagine where this is all going.
absolutely. I'm with you on that.
So as we wrap up this deep dive, what's the one key takeaway you hope our listeners will remember?
I think the key takeaway is this. The real magic of AI isn't just about the algorithms or the data.
Yeah.
It's about the hardware that brings it all to life.
Right.
These hybrid CPUs really do represent a paradigm shift in computing,
Yeah.
unlocking all these new levels of performance and efficiency for AI.
It's exciting.
And as these advancements continue, we can expect to see even more amazing applications emerge,
Yeah.
transforming the way we live, work, and interact with the world.
Well, it's been an incredible journey exploring this cutting-edge technology with you.
Likewise, it's been a pleasure.
And to all our listeners out there, stay curious,
Yes.
keep exploring, and imagine the possibilities that AI holds for the future.
Couldn't have said it better myself.
Until next time.